It's amazing how he's moving.
This is probably the most exciting time to be alive. I think future of warfare is real-life video games.
What's being developed for our military.
We're creating labor at an unprecedented rate. You have to be in control of your destiny as you do it.
How will Phantom know friend or foe when you're facing the enemy?
The standard of safety on this needs to be so exceptionally high.
We are going to have future wars of just machines. I'm Nancy Liu of NewsNation, and welcome to Foundation, which is working on humanoids set to change humankind.
So a lot of the stuff here that you see right now, we're doing almost all of the assembly, sub-assembly inside. So we do this within the US. That's one of the legs that the team's currently building for the next humanoid that they're putting out.
Okay.
A lot of this stuff in next month and a half is going to move next door.
Okay.
And we're going to scale that as our first manufacturing facility to be able to manufacture about one robot a day.
Oh, a robot a day?
Yeah. And then next year, our goal is going to be to manufacture close to 10,000 robots.
Amazing.
It's not easy. It's exceptionally tough, but I think there's a chance where we can do it.
Okay. It's amazing how he's moving. How hard is it to create this?
This is harder than building a car.
Is it?
Yeah. Because the amount of movement and degrees of freedom that a robot needs to have is substantially higher than you need in a car. A car just has a turning radius, wheels move. This thing, on the other hand, is exceptionally more complicated. Yeah. Safer than a car to be around.
And is every version of Phantom coming out, is he new and improved every day? Because you're tweaking and reviving or renovating what you're doing, right?
This is pretty much getting better at a very, very fast clip. So right now, this is our Mach 1.
Okay.
We're about to kind of quick release Mach 1.1, which has substantially more improvements around build quality and reliability. And then there's also Mach 1.2 in works right now. All of that would be done in next 30 to 45 days, while in parallel, the team's building the second generation of Phantom, which is Mach 2.
Would he be bigger and even, I guess, more imposing?
We're currently targeting it being able to lift twice as much than it can right now.
Hello. Hello.
Are you guys remote controlling it or? Oh.
Aha. Hello there.
Somebody's teleoping you.
Nice to meet you.
So the next one would be slightly taller, definitely more stronger and capable, but primarily much more easier to manufacture.
Okay.
So right now you see a lot of these cords and cables coming in and out, parts assembled in a way that have to be done a lot more by hand. Mach 2, the goal is to move a lot to injection molding, to be able to do a lot of these parts at a much cheaper cost, faster, make assembly, sub-assembly much easier, reduce the number of harnesses and wires we have around. That's going to be sometime next year. So.
And when we envision a battle bot, we're all thinking Terminator.
Yeah.
Are you envisioning something that will have kind of be a knife where you can pull out different weapons?
I think it's going to have attachments over time. So the thing that, obviously there's an aspect of having humanoids be able to use existing weapons. So guns, grenades, things like that. But as you're building them, you can also attach other weapons to it, which is kind of similar to the Iron Man suit. The Iron Man suit didn't have traditional weapons. It had a new set of weapons altogether that were much more suited to actually an exoskeleton or a robot doing it. So we think you're going to see some attachments to it over time.
Is it crazy to you that you just mentioned Iron Man, who's a fictional character, and here we're creating something that's like Iron Man?
I mean, yeah. So even what the team's doing what they were doing, which is teleoperating this robot, that is actually from the comic books. Like there are parts of Tony Stark that actually wore a suit, and then very quickly he moved to an Iron Legion, which was like a fleet of humanoid robots that he would teleoperate.
Right.
So no, I think this is like future come to life.
Amazing. So you're telling me you want to do a robot a day? How soon?
This year, by end of this year.
Wow.
Aspirationally starting November.
Okay. Yeah. Okay. And then tell me, how is Phantom getting refined every day? I mean, what's actually happening to improve him?
I mean, so many different things on a bunch of different fronts. So we're making improvements to Phantom with every single build that we do. We learn something new about what we could have designed better. So then you make a lot of design optimizations and improvements.
Right.
So that's Mark 1.1 and Mark 1.2.
Okay.
Then on a daily basis, the robot's getting more capable on the software side. So it can do more tasks, more kinds of things. We're currently training it to do another task that we're going to deploy the robot for next month. So on the software side, there's a massive evolution. And then also so the interesting thing is we're sitting at a point now where you have almost all the material constituents to do this. You have an AI architecture that works, you have a hardware architecture that works, there's manufacturing principles that we can use to scale it. So a lot of the focus and heavy lifting now is on system integration, making all of this work really well together. So on a daily basis, there are tons of system integration work that just enables us to make the robot from hardware, software, all the way to cloud operate much more seamlessly than it did even the day before.
Is that something you can talk about? What, I mean, is this...
That's one of the tasks that the robot has been trained to do, which is essentially taking these parts that come down the conveyor belt, doing QCing the parts, and if they're good, racking it or discarding it.
So really, it's machine learning.
It's all machine learning, and in next few months, if you'll come again, we would have a bunch of these actual replica stations here. So this whole space is going to open up primarily to be able to do replica sites, and then all the manufacturing is next door. So then we'll be able to show you robots doing some of these things.
So we're at this stage. I mean, there are critics out there saying, you know, if we're just at machine learning, I bet how fast can things happen? Like, can we truly have a humanoid that can think and in a battlefield?
Yeah, I would argue you already have that. So if you just like, I don't know if you've had a conversation with ChatGPT or Grok, they exhibit signs of really sound reasoning.
But not physical.
Exactly. So the biggest gap is going from something that is verbal to something that actually acts.
Right.
But that's a much, much smaller subset of the challenge than can they think critically. So the answer is yes, they can think critically. Now, can they think critically and chart their paths to being like, okay, I need to make eggs. So where am I going to go to find eggs? How am I going to poach them? All these different things. And how do you physically do it? So a lot of the AI work happens there now, which is actual what we call action models. So you have high-level reasoning, which is all of your LLMs and ChatGPT that can reason through a very ambiguous task, right? You can go and tell it to be like, get me something healthy to eat. It's going to figure out what's available in your fridge that's healthy. It's going to pick that up. It's going to bring that to you, do all those things conceptually.
Right.
Now you have to put that in action.
Right.
So a lot of the work happens beneath it, which is all of these action models to be able to then make these robots actuate what the high-level reasoning and thinking is.
So I'm guessing how many cameras are here, because Phantom will have to sense things.
It pretty much have 360 view, right? So it has 1, 2, 3, 4 here, 2 on the side, 1 on the back.
So Phantom would be able to sense danger?
It would be able to see it. It has a pretty good human detection model today. So it can essentially see and detect humans.
But would need to be programmed to react.
Would need to be programmed to react. But not programmed. I would not use program as the right word. Would need to be fed more data to train the models to react. which is the big piece that is most exciting about it, right? If you're building this 10 years ago, for it to be able to actually react, to your point, we'd have to write all the code.
Right.
If this happened, do this. If that happened, do this.
Right.
Now all you do is feed it data. And then it learns new things with enough data. And when you give it more data around exceptions and issues, it gets better and better and better. Now, to your point, that is happening task by task. It's not going to be all at once that tomorrow it can do everything. So you kind of go task by task, but you only go task by task until you hit critical mass. At one point, you're going to come to a place where there's going to be a lot of something called transfer learning. So because it's seen 5 tasks that are similar around packaging, unpackaging, 6th, 7th, 8th task it's never seen before, it can zero-shot learn it and just do it. Probably years away from that.
Okay.
But the good thing is you have a model architecture, finally, where you can throw a lot of data and you get pretty good action models on the other side, which means now for the first time in the history of humanity, this is a data problem. It's not a code problem. So you don't need an engineer sitting writing a lot of code. But you do need a lot of these in actual real-world deployments to collect a lot of data.
Tell me about Foundation and the mission of Foundation.
At the core of it, I describe Foundation as an advanced technology company with the mission of building technologies that make life self-sustaining on Earth and beyond. So our goal is really kind of try to build technologies that are going to accelerate the advancement of humanity. A lot of those technologies would have needs currently on Earth, but then as we start expanding out, they would have needs elsewhere. One of those biggest technologies is labor, which is if we can today 100x our labor output, the cost of all goods and services comes quite down. It helps us expand out from just these major metropolitan cities. Like US is pretty population dense in few cities, and then it's like pretty empty. And there's a lot of empty space around Earth. So our goal is to build humanoid robots that can pretty much be deployed anywhere, can start building infrastructure, building goods and services, making the place self-sustainable for humans. So that's essentially the goal.
A big part of the end goal is weaponizing robotics. And talk a bit about the pledge, among other companies, not to create lethal humanoids. But at Foundation, it's the opposite.
Yeah, I would argue that pretending that you don't need to weaponize robots sounds virtuous on face value, but it really isn't. I'm sure you saw the Chinese military parade, and you saw tons of robots as a part of that parade. That cements one thing for sure, that very soon there would be disproportionate loss of life. China will supply those robots to Russia. They will supply those robots to a lot of their Middle Eastern allies. And wherever you have US allies and US troops, we would essentially disproportionately be impacted. Today, a lot of that disproportionate impact is on financial resources, right? Like they have a lot more drones. They have anti-tank missiles. So we're kind of spending about $100,000 for every $1,000 they're spending. That's like untenable, but it's worse when they have almost no humans in the battlefield, and we have lots of humans in the battlefield. So our goal is, we think you cannot be naive, and the approach you have to take is be very thoughtful and mindful, but definitely build these robots for defense use cases and like battlefield use cases, because otherwise there's going to be disproportionate loss of life.
Are you saying then that the future of warfare, when it comes to ground battles, we're going to see basically battle bots?
I think future of warfare is real life video games. So air, land, sea, all of them would be autonomous. And essentially, it's going to be an attack on resources than people. At least that's the hope. And this would be like the first time in history of humanity where that would be the case. But it's seeming increasingly likely that's where we're headed.
Tell me about Phantom.
Phantom is our first humanoid robot, around 5'10", so definitely slightly bigger compared to others. With him, our goal is to build out the most capable and rugged humanoid because, to your point, we want to deploy it in pretty extreme surroundings. So it needs to be able to take a fall, take a beating, work quite rigorously and well, be able to lift more than average other humanoids can do. So the robot's pretty much designed to be very, very powerful and can take a beating and survive. Currently dual use, we're deploying some of Phantoms in car manufacturing, consumer goods manufacturing, but then also in defense use cases with Air Force, Navy, and things like that.
How could Phantom be lethal? Could Phantom be armed with a weapon, throw grenades? How would Phantom be lethal?
I mean, I think there are different stages of progression of what making a robot lethal really looks like. Right now, we don't have what I would say an analogy to a ground drone. You don't have something that can walk into buildings, surveil, go up and down, kind of like tumultuous terrain. So I think initial first set of use cases would be a whole lot of let's create these things to be ground drones. And just like how with air drones, over time you also weaponize them. Initially to be the first line of defense, then to actually be the first line of offense when needed. So that's the natural progression, which is you're going to start off with non-lethal humanoids in the battlefield as first bodies in. We'll probably have human in the loop. Unlike industrial applications for defense, we see for the foreseeable future, you're going to have human judgment in the loop. You don't want these things to be fully autonomous. But you want to have a lot of autonomy as value-add services, so it makes it easier for the soldier to operate the machine. Then the second version of that is going to be exactly what you're saying, mounting a weapon on it, grenades, things like that, being able to go into the battlefield as not just surveilling, but also acting.
You mentioned China showing off their robots. How do we compare? Are we behind? How far behind?
I think my read is we're pretty neck to neck on research and development. What US humanoids can do is about what Chinese humanoids can do. We are behind on manufacturing. US for last decade plus has outsourced almost all manufacturing to countries like China. And that's the biggest test point for us, which is can we actually in-house a lot of this advanced manufacturing and do it at a scale that is about equal or bigger to China. That is a tall order. Having said that, we have been manufacturing in the US, we've been building out teams to ramp up manufacturing in the US, and I'm blown away by the talent. So I do think people in America have the ability to be able to learn these skills or already know these skills. They're highly technical, hardworking. We do have to ramp up. So the piece we cannot get complacent on is our ability to manufacture at scale. But when it comes to R&D, going from 0 to 1, building something that's never existed before, I still believe there's no better country than the US to do that. Almost all of the major innovation happens there. Almost all of the really cutting edge robotics work that I'm personally aware of is also happening here. So I think that trend continues. Now, obviously, we cannot manufacture humanoids in China that would be used in defense applications in the US. So you have to really now in-house this manufacturing ability. And also, even outside of defense, this is a big, this is a massive national security advantage. Because if what you're saying is we're creating labor at an unprecedented rate, you have to be in control of your destiny as you do it. So I don't want to get complacent on the manufacturing side. I feel pretty optimistic, but that's one thing that China is pretty far ahead to us from. Their companies take about the same time to go from 0 to 1, but 1 to 100 and 1,000. China has demonstrated that they have, over the course of the last decade plus, really trained people to do that exceptionally well, and we have some catching up to do.
I know that you've had contracts with the Department of Defense. What can you tell us about what's being developed for our military?
It's pretty much the kinds of applications I talked about. It's robots with human in loop and being first bodies into battlefield, and then eventually weaponizing them. But then there's another side of this, which is actually inspection, repair, maintenance. So being able to do repair a drone, inspect a drone before it goes out, and not having humans do it. So there are both those aspects of it, and both are kind of like labor-related things. I think increasingly, the more we look at what's happening in the active battlefield, we have a high sense of urgency to do the first because of what I said. There's like disproportionate loss of life about to come one way.
We're kind of getting a preview of technology and war with what's happening in Ukraine and Russia and whatever China is providing. How much is that helping in the development of humanoids for war?
I think it's creating a sense of urgency that I don't think we would have had otherwise. So it's definitely good in that regard. It's also in some cases like pretty unnerving, which also creates sense of urgency in trying to see the weapons that US has developed for decades. And then these very cheap drones that can just counteract that so quickly. And that has only increased from every single branch of government to congressional to like federal people we've talked to. It seems like now we have a high sense of urgency. We're paying a lot of attention to this. So this has been helpful in that regard for humanoid development, which is now there is a general consensus that we need to do this. Before that, there was like split focus. We weren't as focused on it.
Talk about adding the layer of AI and an army of phantoms, armed also with AI. How is that going to make a difference?
I mean, so the goal with, I know there are two different narratives for AI. One is this super intelligence overlord. On a day-to-day basis, when we build this technology and we also see other technologies progress, it awful lot sounds like tools. Like they're tools that are supercharging us in a big way. So for us, what AI really means is we need these systems to be autonomous enough that they can do things that humans don't want to be in the loop for, but wait to do things that humans actually want to be in the loop for. So the way we think of like phantom fleet, we want one human to be able to do work of 100 people. It's not that we want to replace the human. We more so want to just like increase the output and the impact that the human has, and more safety, less strenuous environment, less boring. So that's where AI is very helpful. You can just go and tell these things that open up this box, empty it until it's done, keep on doing it, and then you can move on and do something else. And we believe that's really the right place for AI to be able to do some good reasoning around these ambiguous tasks that humans do today, and do it with the supervision of humans at the end of the day.
But I guess with AI, we're learning, how problematic it can be, how many mistakes there are with AI. A skeptic may think, well, how will Phantom know friend or foe when you're facing the enemy?
Yeah, you're absolutely right. And that's where you start off with heavy emphasis on a human in the loop. So even if you look at most autonomous weapons that US uses today, most of them have behind the scenes a human operator that is looking at everything. The pieces that AI has really been able to help flag things, chart paths and trajectories, get there in the most efficient way. But you still need a human to make the final judgment to either fire a weapon or not. And we think for the longest time that is going to be the case. The standard of safety on this needs to be so exceptionally high that like 1,001 chance that it's going to do something, probably even more, that is like a human would not have done. So no, I do think there's going to be heavy emphasis as you build these systems with humans in the loop. And I think the degree of humans in the loop, to your point, will change based on the danger of the outcome. So opening boxes, sorting parts, less dangerous, making the determination of actually firing a weapon more dangerous. And based on that, you're going to have less and more involvement of human behind the scenes.
Anything you'd like to add that you want humankind to know? I mean, it sounds like we're going down this path. We are going to have future wars of just machines.
Yeah. Again, ideally, there are no wars. Having said that, it just hasn't panned out that way. So if you want to be realistic, there are going to be wars. The piece that we really want to do is really minimize human suffering, especially innocent lives, across board. Either something that is a tertiary effect of fighting a war on terror, or soldiers dying in the battlefield. To your point, yes, I think war is going to expand to space. We already are now at a race to deploy an active nuclear site on the southern pole of the Moon. I believe we're doing that because we want to be able to capture that land, and that's the only way, based on how international treaties work around. You cannot just claim, you cannot claim the moon. So I do think there's going to be increasingly more and more scenarios and types of wars that are very tactical in nature, where you can avoid human suffering. And I think that's a good thing. Historically, to be able to expand the scope and scale of consciousness, there had to be human sacrifice. Like, that happened constantly across board, building out the railroads here, coming to the US, colonizing other countries. It's just like massive casualty one after the other. Even like expanding out west was like a dangerous endeavor. It wasn't guaranteed that you would survive, and most people didn't. This is the first time in history where I think we can expand the scope and scale of consciousness without putting human lives at risk. In next decade or two, we would be able to build infrastructure like the pyramids without actually needing to use people to do it. Like, a lot of the stuff, you go to some foreign countries that are not fully democratic, and sometimes you're in awe of being like, how are they creating these structures? And it's the core incentive is still the same. It's like a very cheap human labor in very poor conditions, but there's less care for that. We don't do that in the US anymore, but I do think humanoids and robots generally are going to be the first wave where you can go back to building great things, but without increasing human toll. So that's the piece I'm most excited about and looking forward to.
Morgan Stanley predicts major adoption of humanoids by the late 2030s and the overall market to top $5 trillion by 2050. A healthy chunk of that will likely be humanoids for war. Nancy Liu, NewsNation.
Thank you for watching. Subscribe below and download our NewsNation app right now on your phone, and you will get fact-based, unbiased news for all Americans.